A single mine, smaller than a refrigerator, costing as little as $2,000, and it can snap the spine of a billion-dollar warship clean in half. Since World War II, mines have sunk or crippled 15 U.S. Navy ships, more than every missile, torpedo, and bomb combined. Not 15 small patrol boats, 15 major warships, destroyed by weapons that just sat silently underwater and waited. So here's the question nobody asks. How does the U.S. Navy protect a nuclear-powered aircraft carrier, a ship that costs $13 billion and carries over 5,000 Americans, from a threat you cannot see, cannot hear, and sometimes cannot detect until it's already too late? The answer involves laser systems, underwater robots, electromagnetic shields, and autonomous vessels that hunt mines without a single human in the water. And most Americans have never heard of any of it. This is the full story of a secret technology standing between America's most powerful warships and one of the deadliest weapons ever invented. If you believe in the strength of the U.S. military and the men and women who protect the nation, type proud in the comments right now. Let's see how many patriots are with us today. The threat that keeps admirals up at night. Out of 19 U.S. ships sunk or severely damaged since 1945, 15 were victims of mines. That is nearly 80% of all major U.S. naval losses from one single type of weapon. And these are not the old spiky black ball designs from the World War II movies. Today's mines are terrifyingly smart. Some sit on the ocean floor and listen. They do not explode for every ship that passes. They wait for a specific target. They measure the exact magnetic fingerprint of a vessel, its acoustic signature, the unique sound of its engines, and even the pressure wave it pushes through the water. If the numbers do not match, the mine stays silent. If they match, it fires. These are mines that drift and reposition themselves. Mines that dig deeper into the sand so sonar cannot find them. Mines smart enough to cross-check 3 different sensors before detonating, so they cannot be fooled by a decoy. And the numbers are staggering. China alone is estimated to have between 50,000 and 100,000 mines in over 30 different varieties. Iran has threatened to mine the Strait of Hormuz for decades. In the first Gulf War, a single mine costing $25,000 nearly sank the USS Princeton, a $1 billion guided missile cruiser. One mine, $25,000, $1 billion ship. That is the equation the U.S. Navy has to solve every time a carrier strike group moves into contested waters. So how do they solve it? Layer 1, the invisible shield, degaussing. The first line of defense is not detection. It is invincibility. Every steel ship on Earth carries a natural magnetic field, created by its hull, engines, and electrical systems. Modern influence mines are built to detect exactly that magnetic fingerprint. The moment it passes over the mine sensors, it triggers detonation. The Navy answer is called degaussing, and it is one of the most quietly impressive technologies protecting American sailors right now. Degaussing works by running electromagnetic coils through the ship's hull, cables carrying precisely controlled electrical currents that generate a counter-magnetic field, canceling out the ship's natural signature. Think of it like noise-canceling headphones, but for magnetism. The U.S. Navy developed what is called a closed-loop degaussing system, meaning it constantly measures the ship's magnetic output in real time and automatically adjusts the current to keep the signature as close to zero as possible, even as the ship changes direction or speed. The results are remarkable. Modern 3-dimensional degaussing systems can neutralize 90 to 95% of a ship's magnetic signature. The Navy pushes it further. In 2009, they tested a high-temperature superconducting degaussing system using ceramic superconducting cables instead of copper, delivering the same protection at up to 80% less weight. But degaussing handles magnetic mines. Acoustic mines listen for engine sounds. Pressure mines sense a ship's water displacement. No single technology defeats all of them. That is why the Navy built a complete layered system. And layer 2 comes from the sky. Layer 2, eyes from sky, ALMDS. When a carrier strike group approaches potentially mined waters, it does not sail in blind. It sends helicopters first. MH-60s Seahawk helicopters, equipped with airborne laser mine detection system, fly ahead of the strike group, scanning the ocean surface with pulsed laser beams that penetrate the water and bounce off solid objects below, including mines floating near the surface or moored on cables. An ANAES-1ALMDS reached full operational capability with the U.S. Navy in 2017. It detects, classifies, and pinpoints near-surface mines across wide stretches of ocean, covering the choke points and straits that a carrier must pass through, and feeds data back to the strike group in real time. But lasers only reach so deep. They cannot see a mine sitting on the ocean floor in 300 feet of water. They cannot find one buried in sand. For that, the Navy sends in robots. Layer 3, the underwater robots. The U.S. Navy operates a fleet of autonomous underwater robots called unmanned underwater vehicles, or UUVs, that swim into mined areas without a single human in the water. The primary system is the Mk-18 Mod 2 Kingfish, torpedo-shaped, nearly 13 feet long, 622 pounds. It can dive to nearly 2,000 feet and stay operational for up to 24 hours on a single charge, using a side-scan sonar system. It sweeps the ocean floor and builds detailed imagery of everything below. Mines sitting on the bottom, mines buried in the mud, mines floating in the water column above. Over 90 Mk-18 Mod 2 Kingfish vehicles have been delivered to the U.S. fleet. Then there is the Knifefish, built by General Dynamics Mission Systems. 22 feet long, 2,000 pounds. Where the Kingfish covers wide areas, the Knifefish specializes in the hardest targets, buried mines in high clutter environments, where the ocean floor is full of rocks and debris. That confuse standard sonar. The Knifefish uses low-frequency broadband sonar, a system that punches through sediment and identifies buried mines that other systems simply cannot see. It runs pre-programmed missions for up to 16 hours, maps every threat, and uploads data to the host ship, which can then destroy identified mines without ever putting a sailor near them. The Knifefish has been deployed in real-world operations in the Strait of Hormuz. That is not a test. That is a combat-ready deployment. But finding a mine is only half the battle, and this is the part most people do not expect. Layer 4, artificial intelligence. A single sonar sweep of a contested water produces overwhelming amounts of raw data. Rocks, wreckage, debris, sand ripples. The ocean floor is full of objects that look like mines on a sonar screen. Sorting through all of it manually would take days a carrier strike group simply does not have. So the Navy added artificial intelligence. AI algorithms now analyze sonar imagery from the Kingfish and the Knifefish in near real time. Trained on vast libraries of mine signatures and ocean environments, these systems distinguish between a corroded barrel on the bottom and a live mine, faster than any human analyst. They flag targets, prioritize threats, and deliver an actionable map that commanders can immediately act on. This is operational technology being used right now to protect American sailors. And once a mine is confirmed, specific kill systems go to work. Layer 5, the kill systems, Sea Fox and Archerfish. Two systems handle mine neutralization. The Sea Fox is an expandable fiber optic guided robot, $100,000 per unit. Operators launch it towards a confirmed mine. It swims directly to the target using live video and precision fiber optic control. When it breaches the mine, a shaped charge detonates, destroying the mine and the Sea Fox together. No diver, no risk. The Archerfish is a lightweight, expandable vehicle, deployable directly from MH-60's Seahawk helicopters, equipped with high-frequency sonar and a low-light camera. Operators visually confirm the target before authorizing detonation. The honest reality. Here's where the story gets sobering, and why every American should be paying attention. The Navy retired the last of its battle-tested Avenger-class minesweepers from Bahrain in September 2025. The USS Devastator, USS Dexterous, USS Gladiator, and USS Sentry all decommissioned after more than 30 years of proven service. The same ships that swept over 1,000 mines of Kuwait during the Gulf War. The MH-53E Sea Dragon helicopter, the backbone of the airborne mine countermeasures in the Arabian Gulf for decades, was also retired in August 2025. The new autonomous system is replacing all of it. But as of early 2026, the Pentagon's own Director of Operational Test and Evaluation confirmed that the Navy conducted no full operational testing of the Littoral Combat Ship MCM mission package in fiscal year 2025. It has never been proven in combat. Retired Captain Anthony Cowden, a naval officer with 37 years of service, said it directly. I'm a pessimist when it comes to our ability to deal with the mine warfare threat. That honesty from someone who dedicated his career to this field is worth taking seriously. The threats are growing. China's mines include self-navigating and rocket-propelled designs. Iran continues to develop its capabilities. The transition from legacy proven ships to new autonomous systems is happening right now in real time. What it all means. When a U.S. carrier strike group moves into contested waters today, here's what happens layer by layer. Degaussing systems are active, erasing the carrier's magnetic signature before it nears any threat. Seahawk helicopters fly ahead, scanning the surface with laser systems that spot what human eyes never could. Kingfish robots drop into the water, sweeping the floor hundreds of feet below. Knifefish UUVs probe the sand for buried mines sonar might miss. AI processes all of that data and builds a real-time threat picture. Seafox and archerfish neutralizers destroy confirmed mines without a single diver in the water, and autonomous surface vessels sweep the approach corridors ahead, detonating influence mines safely before any manned ship ever crosses that water. 5,000 Americans on that carrier, 80 aircrafts on the deck, the most power conventional military force ever assembled on a single vessel, cleared by robots, lasers, and autonomous hunters, silently before they even arrive. That is the American engineering and American military investment looks like in 2025. The men and the women of the U.S. Navy do not just sail into danger. They face threats more people never hear about. Weapons that cost $2,000 designed to destroy ships worth billions. And every day, the engineers and sailors behind this technology work to make sure those weapons never reach their targets. If this gave you something real today, something the mainstream news skips, hit the like button and subscribe. The U.S. military deserves coverage that honors what they do. We will keep delivering exactly that.